Hello student, today we are going to study about laws of reflection. Actually, there are two laws of reflection. But before reflection, we want that we are just to discuss about some angles, some features. Now let's see on the board. Here we have a plane smooth surface, that is XY. Like a plane mirror also we can say. XY is our plane mirror or a regular reflecting surface. O is the point on which all the ray incident, that means incident ray. Here AO is the incident ray. OA is the incident ray. The ray which incident on the reflecting surface is known as incident ray. O is incident ray. And OB, we know that after reflections, the ray reflect in the same medium. So OB is the reflected ray. The ray moves away from the smooth surface after reflection is known as reflected ray. And O is the point of incident. At the point of incident, when we draw a perpendicular on the reflecting surface, then that is called normal. So here ON is normal. The perpendicular drawn on the reflecting surface at the point of incidence is known as normal. Hence, we can say AO is the incident ray, OB is the reflected ray, and ON is the normal. Now, we have I. I is the angle of incidence. The angle between the incident ray and normal is known as angle of incidence. That is represented by a small I. And the angle between the reflected ray and normal is called reflected angle, denoted by small r. Clear? Now, according to first law, it's very simple. First law is only applicable. We know that first law is only applicable for the regular reflecting surface. So for regular reflecting surface or for regular reflection, according to first law, angle I is equal to angle R. That is first law. That means for a highly smooth surface, for a plane mirror, for those surface which shows regular reflection, the angle of incidence is always equal to angle of reflection. This is the part which is applicable only for regular reflection. So, according to first law of reflections, we can say that according to first law of reflection, the angle of incidence is equal to angle of reflection. Now, according to second law, the incident ray, reflected ray, and normal lies at the same point of the same plane. Incident ray, we can also say the incident ray, reflected ray, and normal have a common point. So second law of reflection is applicable for both regular reflection as well as irregular reflection. So we can say as a definitions, According to second law of reflection, we can say that according to second law of reflection, the incident ray, normal and reflected ray lies at the same point of the same plane. Or we can also say that the incident ray, reflected ray and normal have a single common point. Clear? That's a part, that is the reflection. Now, let's explain some other things which is applicable for the regular reflecting surface. Now, in absence of, if xy is not present, it is just an supposition. If xy is not here, then the incident ray is just go along the path A, O, A dash. This is the actual path of the incident ray. Hence, we can say that in absence of the smooth reflecting surface, in absence of xy, the ray incident is just go along the path A, O, A dash. But in presence of xy surface, it just move along OB. In presence of xy surface, the ray just moves along OB. Hence, we can say that the angle AOB, A dash OB, is that particular angle by which the incident ray deviates from its path in presence of the highly reflecting surface. So that angle is known as angle of deviation. So we define deviation, angle of deviation, in such a way that that particular angle by which the incident ray deviates from its path in presence of the smooth surface or plane mirror or any surface having which show regular reflections is known as angle of deviation. It is denoted by D. And the angle made by the incident ray with the reflecting surface, that means this angle, is known as angle of inclination or inclined angle. So angle of inclination is defined as that particular angle which incident ray makes with the reflecting surface is known as angle of inclination, and it is denoted by theta. It is denoted by theta. Now, it is the complete figure for a regular reflecting property. It is the complete figure of a mirror which surface show regular reflection. Now, let's see completely. Here, angle AOA dash is equal to 180. No problem. Here, AOA dash is equal to 180. Now, we can write also angle I plus angle R plus angle D is equal to 180. Because here AON is I, that means angle of incidence, NOB is equal to R, that is angle of reflection, and A dash OB is the angle of deviation denoted by D. So these are equal to 180. Now, for regular reflection, we can say for regular reflection, this is according to the first law, it is applicable only for regular surface, that is angle I is equal to angle R. We can write 2I plus D is equal to 180. No problem. So D is equal to, or D is equal to 180 minus 2 angle of incidence. 180 minus 2 angle of incident. Therefore, D is equal to 290 minus angle of incidence. This is equation. This is highlighted that this is equation. This is equation 1. This is equation 1. Completely see. That means for a regular reflecting surface, we can say the actual path, that is AOA dash, angle AOA dash is equal to 180, and we can get by solving this equation that angle of deviation is 2 into 90 minus angle of incidence. Now let's see again this angle with the diagram. This angle is just a perpendicular. It's just a perpendicular. Now by solving this we can say, angle XON is equal to 90. It is the normal angle made by the normal with the surface. There are theta plus I is equal to 90. We can say therefore theta is equal to 90 minus I. This is the condition, 90 minus I. Now put the value of theta in equation 1. We get, now by putting this value of theta in this equation, we get, what can we say? D is equal to 2 theta. This is a very important property here we derive for a regular reflecting surface. Hence we can say, in the case of regular, it is not a part of law of reflection, it is just a part for regular reflection. Whenever there is a regular reflection takes place, then angle of deviation is always 2 times the angle of inclination. At last we can say that reflections have 2 laws. According to first law of reflection, the angle of incidence is equal to angle of reflection, and this law is applicable only for regular reflecting surface. And according to second law, the incident ray, reflected ray and normal have a single common point. And this is just a property of regular reflecting surface, that the angle of deviation is always equal to 2 times of angle of inclination. For today, thank you.